Hello! So here are some more review problems for your upcoming exam on Thursday. So here is one. We have the cube root of 67 minus the square root of x, which is equal to 4, and we are asked to solve for x. Okay, well, solving for x. We have x, which is all the way, it's inside of the cube root, but inside of that cube root, we have a square root. So we want to get to x. So kind of looking at this, I mean, kind of what is kind of like on the outside, right? Holding the whole thing together on the left is that cube root, and then we have x under the square root, but that's way inside of the cube root. So if we go ahead and cube both sides, that's going to kill off the cube root on the left, right? Because the cube root of something cubed is just whatever is underneath that cube root. So if we take both sides and raise both sides to the 3rd or the 3rd power, or cube both sides, what do we get? Well, the cube root of something cubed is, again, whatever is underneath that cube root. So we end up with just 67 minus the square root of x is going to be equal to 4 cubed. So that's 4 times 4 times 4. So 4 times 4 is 16, and 16 times 4, 16 times 4, you might know, you could think of 16 times 4 as, well, 4 times 16, and 4 times 16 you could think of as 4 times, 16 is just 10 plus 6, so that's going to be 4 times 16, and then just distribute, you get 4 times 10, which is 40, and then, well, 4 times 6 is what, 24, so you get 40 plus 24 is 40, 50, 64. So you might have known what 16 times 4 was, or you could think of it like that and get, 64. So 4 times 4 is 16, times 4 is 64. So we get 67 minus the square root of x is equal to 64. Okay, so solving this for x, well, you just go ahead, let's get the x term by itself. If we subtract 67 from both sides, so minus 67, we get just 0 minus the square root of x, so just minus the square root of x is going to be equal to, well, 64 minus 67 is, well, negative 3, right? 67 minus 64 is 3, so therefore 64 minus 67 is negative 3. But then if we just go ahead and divide through by negative 1, the signs change, and therefore we get that the square root of x is going to be equal to positive 3. And then to get to x, well, if the square root of x is 3, we can just square both sides, because the square root of something squared, again, is whatever is underneath the square root. So the square root of x squared is just x is equal to 3 squared, which is 3 times 3, and therefore x here is equal to 9. X is equal to 9. All right, cool. So what's next? Let's take a look at another problem here that you might see on your upcoming exam. We were asked to find the inverse of a function. So let's just say, let's do 2 here. The first one, let's have as f of x is equal to 6x plus 13, and we're asked to find the inverse. So how you can always kind of systematically go through this to find the inverse is you'll have some function, f of x, g of x, whatever, equal to something. Just let that be equal to y. So say y is equal to 6x plus 13, and then just interchange your x and y. So instead of y equals, write x is equal to 6y plus 13, and then just solve for y. So solving for y, let's get the y term by itself. We subtract 13 from both sides, and then divide through by 6, right? So we get x minus 13. Well, that's going to be equal to 6y. Dividing through by 6, we get, dividing through by 6, we get that x minus 13 over 6 is equal to, well, 6 over 6 cancels, becomes 1, so it's equal to y. So y is equal to x minus 13 over 6. And that's our inverse. But to go ahead and put it into inverse notation, right, our function was f of x. So then you just write, instead of y, you can write that as f inverse. Right? So the negative 1 exponent here, that you read that for a function as f inverse of x is equal to x minus 13, all divided by 6. All right. Let's try one other one. It might be a little bit, possibly a tiny bit more tricky. So let's just say another function here, g of x, which is equal to the fifth root. So the fifth root of 2x minus 3. So 2x minus 3. And then we have a plus 1 outside of that fifth root. Again, asked to find the inverse here. We can go ahead, again, let our function be equal to y. So write y is equal to the fifth root of 2x minus 3 plus 1. Then just interchange your x and y and then solve for y. So write x is equal to the fifth root of 2y minus 3 plus 1. Now, solving this for y, well, once we have the fifth root of something, we can take take the fifth power to kill off the fifth root. But since we have a plus 1, we can go ahead first and subtract 1 from both sides. So that's going to give us x minus 1, right, is equal to the fifth root of 2y minus 3. To get to y, we can take both sides to the fifth power. So we'd have x minus 1 all raised to the fifth power would be equal to just the fifth root of something to the fifth power is just whatever is underneath that root. So it's going to be equal to 2y minus 3. Again, solving this for y. So let's get to the y term. We have 2y minus 3. We can add 3 to get to the y term. So if we add 3 to both sides, we'd have x minus 1 to the fifth plus 3 would be equal to 2y. And then to solve for y, just divide through by 2 because 2 over 2 cancels, becomes 1. So divide both sides by 2. And we get x minus 1 to the fifth plus 3 all over 2 is equal to y. But then it's going back to inverse notation. This function was g. So we can write g inverse of x would be equal to what? To x minus 1 quantity raised to the fifth plus 3 all divided by 2. So there we have our inverse function. All right. One more. Let's do, well, we have room. Yes, we have room. If we wanted to show two functions are inverses of each other, excuse me. So let's say we had 8x minus 7 and x plus 7 over 8. So here we compose both of these both ways. We have f of x here and g of x. Oh, and I got a frog in my throat, so I think I'm going to stop right here before I start coughing. But how you would do this is compose both ways, and I'm going to leave it up to you. Can you do f compose g? So do you remember how to do f of g of x and also g of f of x? And can you compose both ways and get back x to undo the function to show those functions are inverses of each other? Take care.